Assalamu alaikum. This is second lecture of physics, and we are starting now from the point where we left in the last class. Just a quick recall or review I want to give you about the things that we have covered in the last class. Now, in the last class, as you can see on the screen, I'm sure it's visible to you, all of you, that we have covered first two chapters plus most of the part of the third chapter as well. Questions are there. You are familiar with the questions, and I've told you the most important questions from chapter 1 and 2. Let me again recall you for those students who were absent in the last class. Uh, from chapter 1, the questions which you have to prepare for the board exams are question 1, 3, and 4. And from chapter number 2, the questions will be question 2, question 3, and question number uh, 4 and 5 also. Convergence, I think you know how to convert from grams to kilograms and from centimeters to meters, from hours to seconds, right? So I don't think that is going to be that much problem. Now in chapter 3, the important questions they have given here, as they're saying difference between scalars and vectors is there, and the definitions you can see we have covered all of them in our classes. And
So please increase your volume.
okay, let me increase my volume. Okay, so today what we are going to do, we are going to start from yeah, and one more thing that I forgot to tell you, that in the last class we have derived all the three equations of motion: first equation of motion, second equation of motion, and third equation of motion. And today, from where we have to start, types of motion and Newton laws, we will be doing in the next chapter, because actually they have given in this chapter. But if you can see chapter 4, the question 1 is again Newton laws of motion. So when we'll start chapter 4, so inshallah we will be discussing in that particular chapter. Okay, motion and its types. So as I have sent you the links as well, you can access the notes from here as well. You can see all the subject notes will be available to you. Okay, motion and its types, right? This is a question and a very good answer with a proper examples, not just one, two examples with each type of motion they have written. And the motion, we know that if a body change its position with respect to its surrounding, then this is known as the body is in a state of motion. For example, a moving car, right? So that is one very basic example of motion. Okay, types of motion. If we can see types of motion, there are three types of motion: translatory, linear, translatory or linear motion. There are two names given to this, and rotatory motion, vibratory motion, or oscillatory motion. So first let's talk about what do they mean by translatory or linear motion. So when we say linear, the word comes from a straight direction, right? So when we say linear, it means a straight path, right? So what will be a linear or translatory motion? It is when the object moves in a straight line or a straight path in a specific direction, and the motion of a body is known as translatory or linear motion. For example, if the car is moving on a straight road, so this is an example of translatory or linear motion. Second one is rotatory motion. So what is a rotatory motion? So when an object spins or rotates about a fixed point or an axis is known as rotatory motion. Example, our solar system, right? You can see sun is a center point and all the planets are in circular motion around that particular fixed point or axis, right? Vibratory motion, a special type of motion which the name is given to and fro, which means it moves around its mean position, and this is known as vibratory or oscillatory motion. A very basic example apart from these two examples can be your mobile phone, right? So when you see that it moves from here to there and again goes to the mean, which is the starting position, which means mean position actually indicates a starting position, right? So when the object is moving to and fro about its mean position, this is known as vibratory or oscillatory motions. So these are the types of motions that we have discussed here. Now, as I've told you, that we are going to go towards these numericals, right? If you can see, the importance are given. Not all the numericals from the chapter you have to do for this year. The most important numericals that can become in this year's physics paper can be 3.1, 3.3, 3.6, and as you can see, the list goes on. Plus, there are three work examples. As I've told you, never there is importance of work examples also, and many times the board the the professors who set the board exams, they have taken the questions from the work examples, and they have given it into the paper. Okay, so this is very important again. So I want you to just open your books. Let me ask you one by one, how many of you have a book? What about you, Rashid? Yes. Yes, Anala, do you have a book?
No, sir.
I have a book, sir.
Okay, you have the book. What about you,
I,
Asif?
I don't know where I have kept.
Center notes.
Okay, you have the notes, but we have to look at some work examples also. Okay, Saif, you have just joined the class. Can you hear me? Hello, Saif, can you hear me?
Yes, sir.
Okay,
Yes.
so today we are doing numericals from the book and from chapter number 3, and you can see these are most important numericals as you have seen. The list is there on the board. So we have here, as I've sent you the link on your WhatsApp groups, that you can access the numericals from the notes here as well, right? So let me go and if you can see from numerical, we can access from here these numericals. Okay, so if you can see in the list, they have given 3.1 as a very important numerical, right? So what they are saying in the first numerical, which is 3.1, I think this is the example they've given, not the numerical. So let me move the pages. Yes, problems are there. And okay, so 3.1, you can see the numerical is here. What they are saying, that you have to find out the time taken by a sunlight to reach the ground If the distance between the sun and the earth is 1.5 exponents power 8 kilometers and the velocity of the light is 3 exponents power 8 meters per second. So in the question, if you can analyze the question in the data, what we have here, we are given up with distance is there, right, which is 1.5 exponents power 8 kilometers. Velocity is there, which is 3 exponent, which is a speed of light, 3 exponents power 8 meters per second. This is incorrect, right? Uh, what they have written, you can see my cursor, this is 3 exponents power 8 meters per second. The unit is incorrect. It is not, it will not be in meters, it will be in meters per second. So do the necessary corrections as well. Okay, so here you can see the formula, very simple and basic formula of displacement, that we know that displacement is equals to velocity multiplied by time, right? So for time, as you have to find out the how much time it will take to reach the ground, so you have to rearrange the formula for time. So then time will be equals to displacement over velocity, right? So this is very simple, that you are just rearranging the equation, and as a result you are making the formula of t, and here you go, you have got the answer by simply dividing the distance with velocity, and you have got the time, the value of time here. Okay, so let me ask you if you have any questions from this. Okay, so moving on towards the next numerical, which is 3.3, and as they have said in the paper that it is important as well. So we are starting problem number 3.3. So if you can see in this problem, what are the things given? Again, if you remember what we have already covered these things in the class and practiced them a lot, these numericals. But let me recall you what are the necessary steps that you will be using while solving this numerical, that you have to go with the proper steps, because in the board exams each steps contain a mark, right? For example, 4 marks are divided into the group of 4 steps, like analyze, when you will make a data of the numerical, which means what are the things given, what you have to work find out in the numerical. This will gain you, you can gain 1 mark from that data. Then the second part mark will be from the formula, if you will be using a correct equation, so then you will be using you will be gaining 1 more mark, then 1 marks for calculation, and the final mark is for a correct result with a proper unit. So don't forget to write the unit with your answer, because that also have some marks. Okay, so as we are moving on towards the problem 3, as you can see in the paper, the next question we have to do, important problems, is 3.3, right? So we are starting from that third problem. So as they are saying, a car is moving with a velocity of 36 kilometers per hour, and it is brought to rest in 5 seconds. Calculate its deceleration, right? So what we have to find out, its deceleration. So if you can see, as they are saying that a car is moving with the velocity, which means initially it was moving with 36 kilometers per hour, which means this is VI, right, which is representing initial velocity. And after they are saying it is brought to rest, so after some time it has stopped, so which means final velocity has become 0. So if you can see this part where my cursor is right now, so what they are doing, they are converting this speed velocity, which is 36 kilometers per hour, into meters per second. And you know the way, the formula, the conversion is very simple, as you have to multiply this value with the 1000 and divide them, divide it with 3600, so you will get the answer of 10 meters per second. Okay, let's move on to the next page of this numerical. Okay, so as you can see, the further things are given, time is given in the data, and final velocity is also given, right? So what we need to find out, final velocity is 0. How come we know this, that final velocity is 0? Because that the body will be in rest. Okay, so when the body is coming to rest, or when the brakes are applying on the car and it comes to a halt, that indicates that the final velocity will be 0, right? So here we are given up with initial velocity, we are given time and final velocity. So we can use the basic formula of acceleration, which is final velocity minus initial velocity divided by time. So if you just have to put the values in, and you'll get the answer. Now if you can see closely, you are getting the answer of acceleration with a negative sign. So what does the negative sign indicates? It indicates that this is negative acceleration, right? So which means this is called deceleration. So again, a very simple question, an important one also, especially for those students who are saying or who are asking me that, sir, give us very important numericals and very important questions. So here you go. This is a list of questions. If you can prepare, I can guarantee you that you can score good marks. Okay, so after this numerical, which is 3.3, we are moving on towards 3.6. So let's go on towards 3.6, which is the next numerical. Okay, so if you can see here that we are moving on towards the next numerical, which is 3.6 here. So here, what we can see that a car starts from rest, which means the initial velocity of the car was 0, right? So VI, if you can see in the data, we have written VI equals to 0, right? And they are saying after 20 seconds, its velocity has become 108 kilometers per hour. So after this, like 20 seconds, which is time given here in the question, the velocity has changed to 108, which means the final velocity is 108 kilometers per hour. Again, if you remember, as I've told you, kilometer per hour is not the SI unit. So whenever you're doing numericals, so you have to convert the units into the SI unit. Then you have to use in the formula. Without converting it, you are not going to get the correct answer. Okay. So as you can see, we have converted it. So now we have initial velocity 0, time is there, final velocity. Again, same question like the last one, right? Again, the acceleration you need to find, right? Rashid, wait, I will answer you. Let me finish this. I will answer you. I've seen your hand raised, so I will answer you. I'll come on to it in after finishing this. Okay. So if you can see this here, that we are again using the same formula of acceleration, final velocity minus initial velocity divided by time. So we just have to put the values in, and you can see we have found the answer, which is 1.5 meters per second square. Okay. Yes, Rashid, everyone kindly mute your mics. Rashid, you just ask your question.
Yes, sir. What about?
You were asking something. Do you have any
Yes, sir.
problem?
But actually, I have a problem about 3.2. That
Okay.
how it convert 36.
36 kilometers per hour into meters per second, right? This is
Yes,
what the
sir.
problem is. Okay. Let me show you on the board here. Don't worry.
Thank you.
Let me show you here on the whiteboard. Okay, all those students who are new, that we are also using the whiteboard as well. It's just like simple to your classroom. So let me show you how we will do conversion if the speed is or velocity is given in meters per second, in kilometers per hour, right? So you can see this. Let me convert this here on the board. Okay, so for example, as they have given in the question that the speed is 36 kilometers per hour, and as a standard we have to convert it into the SI unit, which is meters per second. So how we are going to convert it? We just have to multiply this with 1000, because from kilometers we know that kilo means 1000, so we are multiplying this with 1000 here and dividing it with 3600. What is the reason to divide it with 3600? uh, 3600 represent that in 1 hour there are 3600 seconds, right? So as you can see, we are converting kilometer into meters, so that's why we have multiplied with 1000, and we are converting it this hour into seconds. So we are dividing it with 36 seconds. Okay. Okay, so this was 3.6, similar to the last question that we have covered. Now let's move on towards the next problem, which is 3.9. Okay, 3.9. Yes, this is 3.9. If you can see what they are saying in the question, if you can read carefully, they're saying the car is starting from rest and attains a velocity of 20 meters per second in 5 seconds. So find the distance covered by the car. Okay. So now what we will be using, we will be using three kinematics equation that we have derived. As you can see, we are given up with two velocities: initial velocity, which means the car is starting from rest, which means the initial velocity is 0, and attains the velocity of 20 meters per second means that the final velocity is 20 meters per second. Time is given, distance we have to work out. So first we have to find the acceleration. Why? Because we know that when you will be using the third equation of motion, you have to use the value of acceleration. So for this purpose, first we will be finding acceleration, and then after that you can either use second equation of motion, as they are using second equation of motion. If you can see this arrow which is pointing, this is the formula of second equation of motion. You can even use the third equation of motion in order to find out the distance, right? So it's your choice, but what they are doing initially, they are finding out the acceleration here. Okay, next question is 3.11. So in 3.11, let's see what they are saying. Yes, in 3.11, if you can see, they are saying uh, yes, Asif will come on to it, just wait a second. uh, uh, a boy throws a ball with a velocity of 20 meters per second. Find the time elapsed between the throwing and catching of the ball, right? So what you have to find out that, for example, you are throwing a ball upward, right? So the initial velocity of the ball is given, which is 20 meters per second. And you know that when the ball will reach at the highest point, it will stop, which means that the final velocity here is 0. And the gravity, since the ball is moving against the gravity, so this will be minus 10 rather than plus 10 meters per second square, right? So it will be minus 10 meters per second square this time. Why minus 10? Because the ball is moving against the gravity, so that's why minus 10. Otherwise, just you will be using 10 meters per second square. So what we are finding out, we have to find the time elapsed when the ball has been thrown and then again it has been caught. Okay, so if you can see here that we are using the first equation again, Vf is equals to Vi plus At. So we know that acceleration can be replaced with gravitation, because gravitation, it is also known as the acceleration due to gravity, so we can interchange the symbol. Okay, so what we have to work out here, we have to work out time. So we will rearrange this equation. If you can see closely, we are using the first equation, we are just putting the values in and we are finding out the time. But this is not the answer, as this is only the time that is the ball has taken to move up, right? For example, this is the time here. If you can see, this is the time we have just worked out till this point. So this is what, 2 seconds. But what they are saying here, the time elapsed in throwing and catching the ball. So which means that if the ball is taking 2 seconds going up, it will take the same amount of time when it will fall down. So the answer will be 4 seconds, right? As you can see here. So this is how you will be doing this question 3.11. Okay, so let me ask some question from you, because there are two hands are raised. So let me ask one by one. Okay, we are recording again. So we have discussed this question in which you can see clearly what they are saying. We have to work out the time elapsed, which means the time it will take to reach up, and it will same time it will take to come down. So we have found that out. Okay, so let's move on to the next one. There are two more remaining, 3.12 and 3.13. 3.12 is most probably is the similar question, just the values are going to be changed, but let's look at that question also. 3.12 may what they're saying that a stone is thrown vertically upward with a velocity of 20 meters per second. Find the maximum height reached by the stone and the time of flight. So the time of flight will be the same thing, that what we have worked out the same way that what we have, how we have worked out in the last question. So in the same way, um, uh, you will work out the time elapsed from this question, for this question. And the second thing we have to work out is the height, that how high it will reach, that when the ball is stone is thrown. So if you can see closely, if we read the data or we read the question, what are the things given in the question? They're saying it is moving or it is thrown vertically upward with a velocity of 20 meters per second. Find the maximum height reached by the stone and the time. So we know that initial is 20, final will be 0. Okay, so final, why final will be 0? Again, because when it will go to the height, it will stop. And if you can see, the value of g is in negative again, as Asif Afridi, you have asked the question that why it is negative, because since it is a vector quantity, so we have to consider the direction as well. So when the ball is going up, if the gravity acting is minus 9.8 or 10 meters per second square, and it's coming down, it is similarly plus 10, right? So you have to use it with a plus sign. So you can see the calculations further, right? As I've told you that these are similar to the last questions that we have covered. So you can see if there is any doubt, you can ask. Okay, so let's move on to the last question now, which is 3.13. And let's see what they are saying in 3.13, which is the last question of the book. Okay, so in the last question, they are saying a stone is dropped from a height of 40 meters. Now, this time, the situation is a bit different, right? Now, this time, it is not going like this, right? Rather than it's dropping, like it's going right like this. That's why the gravity or the value of G will be 9.8 or plus 10 meters per second rather than minus, right? So don't use minus here again. And as they're saying, it has dropped from a height of 40 meters. So the height is, or the depth is given, which is 40 meters. So they're saying how much time it will take to reach the ground. So we have to again work out the time taken to reach the ground. Plus they are saying find the velocity with it will strike the ground, right? So we have to find VF as well. So as you can see, these two things we need to work out here. And we are given up, the data is initial velocity is given, height is given, and the gravity is also given, right? So if you can see here, for finding out the height, we are using a SWOT equation again. So which is the second equation of motion. And you can see clearly they are simply put the values in the equation and work out the answer of time. See, this is a mathematical thing, or the steps they have followed in order to work out the value of time. And yeah, they've taken that famous route as well, right? So they've taken it on both sides, as you most of class 10A students are doing, right? So they are also taking the route here on both sides, right, here to find out the value of time. And in the next part, or the last part, if you can see, they're finding out the final velocity, which is Vf is equals to Vi plus 80. Since you have all the things, initial velocity is given, which is 0, acceleration, which is gravity, which is 10 you're using, and time, what you have just worked out, which is 2.82. So the final velocity, if you can see, it is 28.2 meters per second. So this is the last numerical that we have covered. Now let's move on towards the question and your queries. So let me unmute your calls. Okay, so this is
चलेगा सर
what we are doing today. Basically, numericals was the target of today's class, and we have covered all the important problems and solve examples. As I've told you already, you can refer these solve examples from the book 38, 40, and 41. Right, these are also very important. Inshallah, from the next class we will be starting chapter number 4, right? So please do join the class. And you know the class timings, there are 2 days in a week, Tuesday and Thursday. at 10 p.m. Other students can also join the link with your friends. They can share with you. No issues in that. Okay. So see you then for the next class. Allah Hafiz.